Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Zulfadhly bin Azhar, and this is my final year project on video presentation. So I'm doing a research with title Comparative Study of Encryption Technique for Image Security Symmetric Image Encryption, and I have been supervised by Dr. Yusriza binti Yusuf. Okay, so firstly we will go to the introduction. I will highlight some of important information in the introduction, which is the first one is about the importance of data security, where it's very critical for both public and private network. It's covering text, image, and also video data, because all of this will be vulnerable when it is being transferred through network. Okay, so what is the role of encryption? It is where the encryption convert data into a secure format or unreadable format, where if a person cannot decrypt the information, they cannot read it, so it can ensure the integrity and confidentiality. So the focus on image encryption, where in this research I only focus on the image encryption, where I specialize the techniques needed due to image complexity and crucial in sector like healthcare. Next is for my study overview. I'm comparing three types of image encryption, which is AES, PSN, and also chaos-based algorithm. Okay, so for the problem background, the increasing use of digital image is in sensitive sector like healthcare highlight the urgent need for robust image encryption to protect high-resolution medical image from unauthorized access and manipulation. While the advanced encryption standard AES is widely recognized for its robustness and efficiency, the growing complexity of cyber attack necessitate the exploration of advanced techniques such as permutation substitute network (PSN) and also the chaos-based algorithm. So the needs of comparing three of encryption is very crucial, because they offer different security mechanism and also performance characteristics. Evaluating their effectiveness and resilience against modern cyber attack ensure the best protection for sensitive data, information, future research, and also aids in developing more robust, efficient encryption method for high security application. So the aim of my research is to identify the best algorithm in terms of resistant attack among AES, PSN, and chaos-based algorithm. So for the research question, where I have three research questions which is aligned with my objective after this, which is the first one is how the chosen technique, which is AES, PSN, and chaos-based algorithm, is used as an image encryption, because we know all of this technique is widely used in text encryption, but it is slightly different when it's come to image encryption. Next is how to design the experiment for AES, PSN, and chaos-based encryption algorithm to do the encryption on specific image. Finally is which one of the chosen algorithm is better in terms of resistance testing. And for this question, I think we will know the answer at the end of our research at the PSM2. So the research objective, as I mentioned before, the first one is to study the symmetric image encryption of the chosen one is AES, PSN, and chaos-based encryption in terms of resistance and security. To design the experiment using AES, PSN, and chaos-based image encryption algorithm on a specific image. And finally is to evaluate the performance measure on the chosen technique using the AE, which is evidence effect, and PCR, and UAIC for better resistance testing. So for the research scope, where there is four scope for my research. The first one is I will use MATLAB and also Google collaboration for the experiment and testing, and also the Python language to demonstrate the chosen encryption language. The experiment will be run using three simple images that will be chosen. I will show that after this. Comparison will be based on three observations, which are evidence effect, pixel change ratio, and also unified average changing intensity to get the best algorithm in terms of resistance data. The study of image recognition algorithm only cover three image algorithm that I have mentioned before, which is AES, PSN, and also chaos-based image encryption. Okay, now for the literature review, I will explain a little bit about the three image encryption that I have chosen before this, which is the AES, PSN, and also the chaos-based image encryption technique. Where the first one is AES, what is widely known as high-level security and efficient, making it widely used in various applications. It is a multi-round approach involving substitution and also permutation step to ensure the strong encryption. It supports key size of 128, 192, and also 256 bits, providing the flexibility and enhanced security option. Next is for PSN. PSN integrate permutation and substitution to achieve high-level confusion and diffusion enhanced security. Designed to be robust against various types of cryptographic attack, including the diffusion and linear attack. Offer efficiency of implementation with a balance between complexity and also the security, making it practical for real-world application. And finally, for the chaos-based image encryption technique, where it leverages the inherent unpredictability and sensitivity to initial condition of chaotic system for secure encryption, offer a large key space and strong resistance to diffusion attack, making it suitable for high security application. And finally, it provides enhanced security features through complex chaotic maps, ensuring high level of confusion and diffusion. Okay, next we go to the research methodology. We will go through three phases in this methodology, which is the first one is identification of dataset and tools for the image encryption. Where in this phase, the focus is on reviewing and studying the chosen technique. The objective here is to understand the characteristic of our chosen technique, which is AES, PSN, and chaos-based encryption method, and to review the past research related to this technique. This involves analyzing the theoretical foundation, algorithm structure, and also the security features of each method. Additionally, an extensive literature review is conducted to gather insight into their strengths, weaknesses, and application. Relevant data, including the dataset of digital image of varying complexity and size, are collected to be used in this example of this experiment. Next, for the phase 2 is development of experiment for each algorithm. In the phase 2, this involves designing and development of the experiment. The objective of this phase is to create a detailed experimental framework based on the collected data and theoretical analysis. This involves developing a comprehensive plan that outlines the procedure for implementing and testing the encryption algorithm on the selected image dataset. The encryption algorithm are then implemented using MATLAB and Python, leveraging their extensive library for image processing and cryptographic function. Initial tests and debugging are performed to ensure accurate coding and functionality. Preliminary tests of the experiment are conducted to verify the correctness of the implementation, and adjustments are made to refine the experiment design necessary. And the last phase is to perform comparison on image encryption, where this focus shift to implementation, analysis, and discussion. The objective is to run the experiment, analyze the result, and discuss the finding. The AES, PSN, and chaos-based encryption algorithms are applied to collect the image dataset, performing both encryption and decryption process to ensure the accuracy and integrity. Key performance metrics, including AE, NPCR, and UACI, and encryption and decryption time are measured to assess the efficiency and effectiveness of the algorithm. Throughout, security analysis is conducted to evaluate the resistance of the encryption algorithm to various types of attacks such as brute force, statistic force, differential attack. The statistical methods are used to analyze the performance and security data, comparing strengths and weaknesses of all our chosen algorithm. The results from the experiment are analyzed and discussed. Highlight the key finding, insight, and implication for the field of image security. Okay, so this is the research framework that I have explained about the phase. And okay, Okay, so is the image of that will be used for the experiment, which is three PNG image, which is Lena.png, Papers.png, and Baboon.png. Okay, so the progress that achieved for PSM1 is for the first objective for the PSM1 has been achieved, which I have studied all the image encryption method, and also have collected data for the experiment. For the second objective, I have started but not finished. I have not yet tried to run the coding, but I will try set up the environment. And finally, for the third objective, which is for the analyze thing, it only can be done in PSM2 because it's when the experiment phase started. Okay, so for the conclusion, this research compares the effectiveness of AES, PSN, and KR-based algorithm in image encryption. AES is widely recognized for its robustness and efficiency. PSN provide high level of compression and diffusion, and KR-based technique of enhanced security through unpredictability and large key space. Understanding this strength help in selecting the most suitable encryption method for securing image data, particularly in high security environment like healthcare. Okay, so that is all for my PSM1 video presentation. Thank you and Assalamualaikum.